So feature slicing. What is, what is this concept and how this concept are helpful to our features engineering? Okay, let's try to understand this concept through an example. So suppose the previous examples that we have taken predicting the gender, the same examples also here we have used to, to get the idea of the feature slice. Suppose let the features we have, okay, height, weight, hair length, and eye color. Let's these four features we have, and these things we have called the x's. Based on these four features, we have to predict what will be the gender. Predict, we have to predict what will be the gender. That's things, and these things are called the yi. So, so this suppose and suppose for these four features, instead of using these four features, if we have other features like country, let there have another features like country. So if this country, supposedly if this country has two type of country in our data set, let one is India and another one is USA. Let if this happen, so it will be better if we just visualize these things through a picture. Suppose let's this is our data set. In this data set, we have these four features and one feature country, and here corresponding the yi's. These are the four features we have. Here this is the height, weight, hair length, eye color like that. And here we have country, and here we have gender. Here we have gender. Okay. And here supposedly in this data set we have the 80% data for the country India and rest 20% data we have for the country USA. Let for this data set, on this data set we have these 80% data total here we have 80% data for the country India. Sorry. And here we have only 20%. And this 80% data is responsible for the country India. And this 20% data is responsible for the country USA. Okay. If these things happens. So this is an means and this type of data is imbalanced data. So the major number of data is coming from India and only few data is coming from the USA. So this kind of data is called mis means is not balanced data. If this thing happen, then the model, suppose let's these are the data set D. This is the data. If with this help of this data, with this help of this data D, if we make some model onto this data M, if we make some model, then this model actually end of the day for a model we have to minimize the loss functions. It will be square loss, it will be the means hinge loss. It's depend on the situations, model to models. Means at the end of the day we have to minimize the loss function. We have to minimize the loss function. We have to minimize this. And it means you can think like it is in average log loss. Average log loss type of thing. Okay. So if we you simple use this whole data D and build the model M, so the model M may not be perform well for USA since minority is data come from the USA and majority of the data coming from the India. So it will perform better for India. This model performs better on the India and it it's not perform well. It's odds for the category USA. Since majority of the data coming from the India because of this reason. Imbalanced data is this one is because of this reasons these kind of situations are. Okay. Now the question is how will find which category is dominates the other. How will find questions is how will find how will for which category the data is imbalanced. How will find this thing? That is the big question. Now let's try to what this concept. How will find how to how to find for which category this data is imbalanced. So so simple by using the data D, we have built the model M, we have built the model M, and on the based on the output of this model, based on the output of this model, suppose let from this data D, we have extract some randomly extract the D test data. Supposedly. So for this data D, we have randomly extract the D test data from this data. Extract the D test data. Randomly doing this job. We have randomly these things and extract the D test data onto it. And on this D test data, we have to find the accuracy of the models. We have to find the accuracy. We have to justify the accuracy. Accuracy means we have to maximize the accuracy or error. We have to minimize the error on this data set. And since this test data is coming from the D is imbalanced. Similarly, D test is also imbalanced. Typically, we have seen that in the test data, this ratio is for 80 to 20. Okay, since D is imbalanced in 80 to 20 ratio for India and USA, similar things also happen for the D test also. Okay, so if you plot the error functions, the PDF of the error functions, if you plot the here suppose let here it is the error, here this side it is error, and here it is in this side it is the PDF of this error. Then this kind of if you find this kind of plot, suppose for the error, if you find this kind of picture, and for the USA if you find this kind of, this plot is responsible for the India and this plot is responsible for the USA, then you find that the error is less error it will for the India, and it will be the maximum error is coming from the USA. Since from this error plot we can understand that this model is better for the India and it's not better for since that's it. On this picture, see it. Less amount of error we have find. But in USA, its error is increased. If your error increased in PDF, see this picture, and you can understand. Okay, just see it. Now, how to remove this solution? The strategy is how to remove this drawback. How to remove this drawback? So, to removing this drawback, the one strategy is slicing the data. So, we have the data set D. I will slide it, the data set D. So first we have to slide it in the D India and D USA. I will slice it, just see this data. In this data, 80% data coming from the India and 80% of the data coming from the 20. By simply using this plot, we can understand. Okay. So first we have to slice the whole data for India. This 80% are from India and this 20% from the we call DUSA. These things we called this data is called the D India, and this data is called the DUSA. Okay, these things. This is the simple. And onto this data, onto this its slice of the data, we have to build our model. So onto this slice of the data D India, we have to build the model M1, and for this data D USA, we have to build the model data M2. We have to model M2. So this data is we have the 80% of data, and in this data we have the 20% of the whole data. So the model M1 is must be better. So these two models will be must better for this model. Since we have applied the individual data set on individual model. So the seed category, the Indian peoples and the USA peoples are totally different. So it depends on the height. In general, it depends on the environmental conditions. It is in domain knowledge we have seen that average height of an Indian people is less than the average height of an USA people. Okay, it's kind of domain knowledge we need. By simply using this kind of probability and plot of the probability density functions to error functions, we can understand this thing. This is an imbalanced data. So if you slice the whole data and onto the after the slicing data, if you build the individual model on the individual data sets, then it will give us better output. Okay. So we make the slicing of the whole data based on the features when we see these two type of situations occurs. So let's write down. So the slicing of the data slicing the data based on a feature features it's occurs when we have find these two type of situation. First one is if category 1 and category 2 are very different. So category 1 and category 2 are imbalanced. Number 2 is if there have not sufficient number of points in each slice, in each category. Imbalanced, and second is the sufficient number, and the number two conditions is if there have not sufficient number of points for each slice. If there have no sufficient number of points in each slice, or in other language, if you call it an imbalanced data, then we have to make this slicing visualization technique. So in this slicing technique, will give the better output. So let's try to understand this thing through an example. Another example. So this when we consider and suppose e-commerce world. In this e-commerce, suppose like Amazon or Flipkart, they have the desktop app as well as they have the mobile app. So on this data, if you just think, suppose in e-commerce world, there are two type of data there have come from. One is coming from the mob desktop app. The data is coming from the desktop app, and as well data is coming from the mobile app. Suppose let the data that coming from the desktop app is about 30%. And the data is coming from the mobile app is about 70%. Okay, let these things happen. So in such scenario, this is the 7 is to 30 ratios. In this scenario, the model that we are going to make, that might be give different kind of result. That might not be give accurate result for desktop or some for mobiles. So since the mental ability, the users of the desktop and the mental ability of the users of the mobiles are totally different each other. So it might not give the same kind of results. In such scenario, it will be better if we slice the data. In such scenario, it will give the better result if we slice the data. On this, instead of using the M1 and the whole data set, if we build a models, if we build a model, only a model onto this desktop app, if we build a model M1, if we build a model M1 only using this desktop, and if we make and by using the mobile data, if we make the another model M2, then these two models will give more accurate output. It predict more accurate output than this model M. This is accuracy is increased. Its accuracy is increased. Very simple. For instead of using here, hence mental thinking. If you just to try to think this leaks like it, like a way that we have to predict the users who will buy more things. In such scenario, if you see the mobile user, it's the mentality of the mobile users, because it's the small kind of screen here, and here is not showing much informations about the some product. So in such mobile data, the mentality is to buy the cheaper price thing. For the desktop user, it's mentality to buy a more higher price things like that. Okay, so this is the simple application. So I think from this discussions we got the idea how the feature slicing technique will help us to build a more accurate model. Instead of using the sample, if instead of using this whole data, if you slice the data set to chunks and take the individual chunks and build the individual model, then you will give the better output. Okay, I think you got the idea of this discussion.